Good morning everyone and welcome to today's class. That is, today we'll be discussing the revision facts of force and pressure. So students, already we have discussed about the various types and about the various forces, the types of forces which are occurring in this particular chapter. The forces, the different types of pressure, the different types of forces and their application. So today we'll be doing the recapitulation of the entire chapter, that is force and pressure. So as per you can see, we started this chapter in 10 December and the first class, our outcome was to enable us to analyze the different effects of force and balanced and unbalanced forces. So students, you can have a look on the force. What is a force? A force is basically a push and a pull. A force to move an object away from our bodies is push, and a pull is when we apply a force to move an object towards ourselves. So whenever we apply force, it is called push, and whenever we apply a force to pull towards us, it is called a pull. So we are moving an object towards us is pulling, and we are pushing an object, or we are moving object away from us is pushing. So combination of push and pull, you can see in these following examples. You have playing a guitar is a combination of both push and pull. Then scrubbing the floor is a combination of push and pull. Then sawing wood, when we saw wood, it's a push and pull. So these are the examples of force having push and pull. Then we have the forces are due to interaction. So whenever two forces, students, they attach, or whenever two forces come into play with each other, they have to interact. Because if you need to apply force of one body on the another, you have to make an interaction. So as a result, forces are due to the interaction. Next we have exploring forces. So here you can see there are two forces, F1 and F2. F1 and F2, both the forces are applied on the same direction. So when both the forces are applied on the same direction, it is called unbalanced force, and the force gets added because they are being applied in the same direction. Next we have unbalanced forces. Now what are unbalanced forces? Now suppose you are applying F1 and again you are applying F2. So if F1 is more than F2, then the box will go this side. And if F2 is more than F1, then the box will go this side. So the direction of the box depends on the magnitude of F1 and F2. Similarly, if F1 and F2 are equal, which means the box will move nowhere. It will stay at that particular position. Next we have the same thing which I told you, that if I apply the same force F in opposite direction, then it will cancel each other. Then we have the different effects of force. Force can make an object to move from rest. Then force can stop a moving object. Force can change the speed. Then force can change the direction, and force can also change the shape. Then we have the examples. If stretching a rubber band, pressing a sponge, or squeezing a spring. What are the after effects of these forces? After we stretch a rubber band, it becomes like this. After we press a sponge, the water comes out. And after we squeeze a spring, it again comes back to its original position. So an object will return to its original shape and size after being squeezed, pressed, twisted, or elastic. So these are the examples of day-to-day life where we apply force and we can change the shape and motion. So now students, we come to the most important part of this chapter, that is types of forces. So first force is contact force. So contact forces are those where the two bodies are need to be in contact. And non-contact forces both where the bodies should not be in contact. So contact forces, students, we have muscular force and frictional force. Whereas non-contact force we have magnetic force, electrostatic force and gravitational force. In these forces, the two bodies need not touch each other. But in muscular force and frictional force, the body has to touch with each other. Next we have contact force. So muscular force is the force exerted by the muscles of the body. And obviously it is contact because it has to be in the touch. Next we have force of friction. Now force of friction is actually opposes the motion. Now suppose you are moving from this side, the force of friction will act from the opposite side. Next we have non-contact forces. So what are the non-contact forces? The forces which do not require any contact are called non-contact force. Magnetic force is a non-contact force. Electrostatic force is a non-contact force. Gravitational force is a non-contact force. The definition we have already done in the previous classes. Now pressure. So I am just giving you a recapitulation of the chapter force and pressure. Now pressure depends on force and area. How? So it describes how a force is spread over an area, is what is the unit, and it also tells us how much force is acting and to what extent that particular force is acting. So pressure is actually force per unit area and its unit is Pascal. If the area is smaller, the pressure is more on the surface. So it's a vice versa. If area is more, the pressure is less. And if area is less, then the pressure is more. Then we can increase the pressure by reducing the area. Here's an example with you. A sharp knife has a very small surface area so that it can be cut easily. Then high pressure on the surface of ice means when you are working with ice, you have high pressure, so the ice melts due to the pressure and you can walk smoothly. Next we have when a force is applied to a nail while putting in the wall with a hammer, the surface area should be less. And obviously this is a very common example. You people know that spike shoes are worn by footballers so that the area is less and they can exert more pressure on the ground and take the grip. Rally cars, they need a very high pressure of tires because the tires are very small, and as a result that high pressure helps them to maintain the balance. So you can also reduce the pressure by increasing the area. This is example number 1. The skis, where people do ice skis, the area is more, so the pressure exerted on the snow is less. Then this is an example of tractor. A tractor moving on soft ground has wide tires so that the reduced pressure on the ground and they can easily move. Very important and very well known fact, the school bags which you are taking, some has broader belts, some have very small belts. So those who are having broader belts, they feel less pressure because the area is more. And if you take a very small thin